Hey there. Today we are going to be looking at solving equations. When we solve equations, our goal is to get x or n or whatever variable is completely by itself. The way that we get x or n or whatever variable we're dealing with completely by itself is we use inverse operations or opposite operations to undo whatever is happening to our variable. If you look at your notes, there's kind of a checklist we're going to follow. I'm not going to write that checklist out on here. I'll kind of walk you through it. So you may have noticed in the last two down here that there's some distributing to be done. Typically that's what you do first, unless you don't have distributing, which is what you see in the first two. So let's start with these first two. I don't have any parentheses anywhere, so that means I don't need to distribute anything. So I need to get rid of any addition or subtraction that's happening, and then last but not least, get rid of any multiplying or dividing, which is like backwards order of operations, kind of. So I am subtracting 1. To undo subtracting 1, I add 1 to both sides. That gives me negative 6k here because negative 1 plus 1 cancels. 95 plus 1 on the other side gives me 96. Anything we do to one side of the equation to cancel something out, we have to do that same thing to the other side of the equal sign to keep the equation true. We're closer to being done. K is not completely by itself yet. We have negative 6k, which means negative 6 times k. To undo multiplying by negative 6, we divide by negative 6. Again, we do that on both sides. Negative 6 divided by 6 is 1, so it cancels, which is what we want. So we get 1k, or just k. And then 96 divided by negative 6 is negative 16. Once you have your variable, which in this case is k, completely by itself on one side of the equal sign, number on the other, you're done. Let's try another one. So looking over here, what's happening to x? We are adding 6, and we are multiplying by 7. We undo the add 6 first. The opposite of adding is subtracting. So I'm going to subtract 6 from both sides. That gives me 7x equals, because these cancel, negative 91. Closer. Last thing we do, undo 7 times x. We're going to divide both sides by 7. And we end up with x equals negative 13. So those two nice little two-step equations will be as simple as we're going to go. We're going to get a little more complicated and build as we do some more. Like I already mentioned, we have some parentheses going on here, so our big clue is we need to distribute as our first step. Remembering from your distributive property, that means after the equal sign here, I'm distributing a 5 to everything inside the parentheses. So the 70 equals on the other side isn't impacted by that, so that stays the same. 5 times negative 4 is negative 20. 5 times n is 5n. From here we want to solve this. These look kind of like what we started with back here, so same process. We're going to undo any addition or subtraction. So right now we have minus 20. To undo minus 20, we add 20. Those cancel. 70 plus 20 is 90, equals 5n is all I have left on the other side. And then last but not least, to get n completely by itself, I need to divide by the number in front, which is 5. So my final answer is 18 for n. You can write your answers either way, 18 equals n or n equals 18. Those both mean the same thing. Moving right along. This next one is also a distribution problem. We have a negative in front of parentheses. Remember, when you have a negative in front of parentheses, that's the same as a negative 1. So draw that negative 1 in if it helps you. So 16 equals will stay the same, nothing changes there. On the other side, we need to distribute negative 1. Negative 1 times 2 is negative 2. Negative 1 times m is negative 1m. You don't have to write that 1 there, but I'm doing it just to remind ourselves that there's something we need to do there. Moving right along. Next up is we undo addition or subtraction. So I'm going to undo minus 2 by adding 2 to both sides. 16 plus 2 is 18, equals negative 1m. And then our last step is to divide. Divide by the number in front of m, which is negative 1. You end up with m equals negative 18. Quick side note here, if here you had 18 equals negative m, That is a really messy m, sorry. If you wrote that as negative m there, you would still have one more step to do. We don't want negative m, we want just regular m. When you don't see that negative there, you can draw it in to remind you that you do need to divide by -1. Either way, you get the same final answer. Let's try some more. Give me a moment here to kind of get rid of these and get ready for our next ones. Okay, so a few more here coming up. Let's just dive right in. So with all of these ones that you see now, we have some same side of the equation like terms that can be combined. If you have same side equation or like terms on the same side of the equation, do those before you start undoing addition and subtraction and things like that. So for example, this one, I have v's I can combine. 6v minus 6v, since they're on the same side of the equation, we're just going to combine them like regular combining like terms. Remember, when you combine like terms, you just add or subtract the numbers in front, and the variable part stays the same. So 6 minus 6 is 0, so technically I get 0v here, but remember that 0 times v or 0 times anything that cancels, we can think of that as just being 0 equals 0. This right here is one of our special situations. We have no variables left at all. We have the same number on both sides of the equation. Whenever all of your variables cancel out, which is what happens here, whenever all of your variables cancel out, then we are in a special situation which is called all real numbers. Why is it called all real numbers? I can pick, let me get rid of that slash there, I don't like it. It's called all real numbers because I can plug in any number I want for v. As long as I plug that same number into both spots, my equation is going to work. So I could pick any number I wanted to, 2, 3.5, pi, whatever, and my equation would work. So all real numbers. When you get a situation like that, again, same number on both sides, equal sign, no variables left, you don't get v equals something, you just write the words all real numbers instead. Let's keep trucking. All right, so here, do I have any like terms that are on the same side of the equal sign? Obviously, there's nothing to combine on this side. On the other side, I can do some combining. So 4n stays the same, sorry. 4n plus 3 is 7. From here, it looks more like problems we've done before. We know we need to undo plus 7 first. So I'm going to do that by subtracting 7 from both sides. Cancels here, which is what I want because I wanted that to get undone. Over here, 7 minus 7 equals 0. So we do need to have a 0 if everything on one side of the equation cancels. One more step to get rid of that 4 in front of the n. That means 4 times n, so I undo that by dividing. 0 divided by 4 is 0 for n. So it is perfectly fine to get 0 as a solution. Don't let that scare you. Doing some more fun here. We have a lot of things that can potentially be combined here. On the left-hand side of the equation, I can combine all of these things. So the n stays the same. -6 plus 7 is 1, plus 1 is 2. If you'd like, you could do -6 plus 7 plus 1 all in one step in your head or in a calculator like Desmos. Other side, can anything combine? Sure it can. I can combine my n's. So the 8 part stays the same. 7 minus 8 gives me -1n. Or you could just write that as minus n, that would be fine too. From here, this is something we haven't encountered yet today. We need to get all of our variable stuff on one side of the equation, all of our number stuff on the other. I always like to start with variables. So I like to usually get my variables on this side of the equal sign, which means this one needs to move. To move is the same idea as that we did back here. I need to do the opposite. So the opposite of -1n is +1n. If I'm doing that to one side of the equal sign, I've got to do it to the other. Make sure you're doing it to the n on the other side, so I add one n here. Those cancel, that's what we wanted because we want to get our n's all on one side. 1n plus 1n is 2n. And then now this looks more like things we're familiar with. We need to undo addition of a number, so we subtract. 8 minus 2 is 10. And then our last step, as usual, we need to divide by the number in front of n. We get n equals 5. So, nothing really too scary, just more steps to do. Let's try another one. So I don't have any like terms to combine on this side. I don't have any like terms to combine on this side. So where I need to start is by getting my variables on the same side. I like to get my variables on the left-hand side, so I need to undo positive 2p. The opposite of positive 2p is negative 2p, so I'm going to subtract 2p from both sides. So when I do that, these cancel because 2p minus 2p is 0, but they also cancel here because 2p minus 2p also equals 0. So all that's left on this side is just 15. All that's left on the right side is just 8. So this is yet again another special situation. We only have two special situations. This is my other special situation, which we call no solution. So no solution is what happens when we get two different numbers on either side of the equal sign, but all of our variables have canceled. There is no way in the world that the number 15 will ever equal the number 8. So no matter what number I would potentially plug in for p back here, no values of p will make these two numbers ever true. Since this equation will never work correctly, this equation is called a no solution. So, pausing for a second before we do two last problems. Same number on both sides of the equal sign, no more variables, is all real numbers. Different numbers on either side of the equal sign, but no more variables, is no solution. We'll occasionally run into these two things, but most of the time you'll be dealing with something where you get x equals a number, n equals a number, whatever. All right, we'll do two more for today. We're going to keep doing a lot of practice with solving equations, probably 3 or 4 assignments worth of stuff. It's a very, very important skill for us to have for Algebra 1 and as you continue on with math. Okay, there's one. There's the other. All right. So, what do we need to do first? If we have distribution, that is the first thing we need to do. I do have distribution here, let's take care of that. Negative 2 times 1 is negative 2. Negative 2 times negative 2n. Negative 2 times negative 2 is positive. 2 times 2 is 4. Don't forget about your n. Everything else about that equation is going to stay the same. Now, do we have any same side like terms? Nothing combines on the right hand side because this has an n, this is just a number. But on the left hand side, I can combine the two negative 2's. Negative 2 minus 2 is negative 4. The 4n part stays the same. Now, we need to get all of our n's on the same side of the equal sign. I like to put all my n's over here, so I'm going to do the opposite of whatever's happening to this n. This is a negative 2n, or a minus 2n. The opposite of minus 2n is plus 2n. So I'm going to do that to both sides. 4n plus 2n is 6n. And now life is a little bit easier to deal with. Undo minus 4 by adding 4 to both sides. This will get all of my numbers on the same side of the equal sign. All I have left here is 6n. 14 plus 4 is 18. And then one more little step. Last little step to get n completely by itself. I need to divide both sides by 6. Final answer here is going to be n equals 3, because 18 divided by 6 is 3. All right, last one, finally, yay. So, where are we going to start? Nothing I can really do with the left-hand side. Those can't be combined. There's nothing to distribute. So left-hand side stays the same. Right-hand side, I do have some distributing. 3 times 8 is 24. 3 times negative 1x is negative 3x. And then that minus 4x stays the same. Now, do we have any same side like terms? Again, nothing can be done on this side for now. So that's going to stay the same. On the other side, 24 is my only number term, so it stays the same. Negative 3x minus 4x gives me negative 7x. Now, we want to get our x's on the same side of the equal sign. I'm going to move this one over here. To move that, I do the opposite. The opposite of minus 7x is plus 7x. Negative 6x plus 7x is 1x. But remember that 1x is the same as just x. I'm going to write that as just x, but if you want to write it as 1x, that is fine. And now we undo addition or subtraction. We have a plus 32. The way I undo plus 32, which is the opposite, which is minus 32. All I have left here is x. Other side, 24 minus 32 is negative 8. Since there is nothing in front of x other than 1, if you still have that, we are completely done. So if you had 1x equals negative 8 at that point, if you'd written the 1x equals negative 8 is the same as x equals negative 8. So technically you're done. Because if I divide by 1, I'm still going to get negative 8. So hopefully now you're feeling pretty good with solving equations. We'll keep doing more practice with this. I hope you have a great day.